Hello, this is the Fox MT-80AZ microprocessor trainer board. It's based on the Zilog Z80 chip, which is a descendant of the Intel 8080. The purpose of this board is to give people the ability to learn assembly language programming. Now, this particular board is a later version that this company called E&L designed and produced. The earlier one was known as the MT-80Z. This is the Fox 2 MT-80AZ. So I have the user manual for the earlier version, but not the one for this one. So I downloaded the user manual for the earlier model, and I'm having to walk through it and see what's different. I cannot find the user manual or the schematic for this particular board on the internet, so we'll just bear with what we can figure out here. So I'll show you what I've learned about it. I bought this off eBay and it appears to be working. Okay, so all you need to power this board is a 5-volt DC supply. You do need to provide about 700, 800 milliamps of current. I guess I'm running at about 810 milliamps right now. So, 1 amp supply would probably be just fine for this. So in this case, I soldered the leads of the power supply, my supply, right to the board, mainly because I didn't have the right DIN connector mating plug. This is kind of an, I don't know, maybe sort of odd. This is, they call a 180-degree DIN plug. So there's 5 pins here, and the first pin to the last pin, they're 180 degrees apart along that arc. So this socket you could actually replace and put anything you want in there, another more normal DIN size plug. Okay, so what you can do with this board is you can load programs into memory. It has a monitor program that's loaded into this PROM here. RAM is in this chip. This socket is open and allows you to expand the RAM. The RAM on this board starts at address 4000, and I'll show you that here by pressing the address button. So the monitor knows where my first address location is that I can change. Of course, anything below that, anything in the PROM, you can't change. The left side of the display is the address. So remember, these are hex digits. So each hex digit represents 4 binary bits. So this is hex 4000. And then these two displays represent the 8 bits of data, or 2 hex digits. So this is a whole lot easier than say trying to program the early MSI 8800, where each switch represented the input of 1 bit for either the address or the data. So here we're just changing addresses by 4 bits. So if I wanted to change this, I would just press address. The decimal points light up here telling you this is the address, this is the field that you're going to change, and then I can change that to 4001, for example. And if I press data, the decimal points switch over to the data field, and I can put a value in there, say FE. Okay. And then one convenient thing that they have is they have a next and a previous, so I can go next and load something else in there, and next, and so forth. Okay, and I can go previous, so I can walk back and look at what I've loaded into those various locations. Okay, so here you would load your program in, address location by address location. You'd put your opcodes into the data fields, and away you go. So when you have a program loaded in that you want to run, you would tell the program counter to start at a particular address. In this case, it's at address 4000, and you'd press go. Now, I don't have a program in here, but we'll do that in the next video. And also what I'll do is this board also has the capability to record and play back programs using what in the time was a cassette interface. So it's just audio beeps and blurps. But it also will work with a laptop recording just a simple MP3 file and playing it back. You have to fuss around a little bit because the levels that these expect are based on a early, cassette player, and typically our systems don't put out so much voltage. So we'll talk about that later.